Good morning.
Good morning.
Did everyone get their homework?
I did, but I haven't checked it yet.
Okay.
Okay, Mr. Miller, why don't you spend a few minutes talking about the homework and maybe problems you saw?
Sure, yeah. The homework was pretty good overall, right? You guys seem to know how to do your algebra, which is good. That's definitely going to be required. Some trig stuff might be, might benefit some of you to, either spend, a little bit of your own time going back and going over some trig functions, stuff like that, or going into like the tutoring center or something like that. Again, the format, I'll remind you all that we need one PDF. So no pictures, anything like that. Has to be a PDF. And please try to look at the PDF before you send it out. Some of them were like sideways or upside down. So I tried to bear with you for the first assignment, but as the semester goes on, that's just going to be more difficult for us to deal with, grading and stuff like that, or me really. But yeah, just give it a quick look over and make sure that it looks like a homework assignment. That was the other thing. This is, it's homework. It's not scratch work. So, if you go through a problem once and maybe you messed up and, you scratch some stuff out, recopy it again before you send it out. If it's difficult to read, if I have to look all over the place for if problems are out of order and stuff like that, it just makes everything more difficult. So just take a few minutes, before you actually send the homework out to look at it, make sure it looks good.
Yes. I'm sorry about my homework being upside down. I can't help that. The printer doesn't want to put it all right side up. But at least they were all the same orientation this time.
I hated writing out the limit as x tends towards a of some function equals the limit of x tends towards a.
Again, I am very, very sorry about that. And I can't control how my scanner is doing it. I don't know why it always scans upside down or sideways or something like that, but it is impossible for me to get that thing to stay, everything to get upright.
Okay. But he was saying, Mr. Miller was saying something about this limit thing. Say that again.
Oh yeah, write out your limits.
Yeah, until you take them, it's got to have a limit as h goes to 0 or a limit as x goes to a or whatever in front of the expression. Okay, it does not go away until you actually can direct substitute.
Yeah, so I, again, that was something that I didn't take off points this time, but I wanted to warn everybody that that is the sort of thing that I absolutely would take points off in the future.
Yeah, that's good. And also take points off if it doesn't come in as one PDF file. Okay.
Yeah, that was another one I tried to be real flexible with this first time, but again, yes, not all the submissions were in the PDF format. I did send separate emails, or not separate emails, but with the homework that I returned, I did with a few people send some emails about just little warnings about formatting errors and stuff like that. But yeah, for the most part, the homework was pretty good. So keep up the good work. This is a tough class. You're gonna have to put in a lot of time, um, and so you gotta bear with it. Um,
Right.
um, oh, the other thing was, and you don't have to do this, but if you wouldn't mind, if you happen to be a math major, and you submit with this next homework, if you don't mind just saying, like, oh, by the way, I'm a math major or something like that. I'm not going to grade you more harshly for that. If anything, I'll just make, slightly different comments maybe, or something like that. So, um, yeah, I was just kind of curious about, who the math majors were. But yeah, like I said, we had, a few people who had, full points. There was a lot of you who had 18 or 19 points out of 20. So overall pretty good job. But yeah, it was mostly just silly
Right.
little formatting things and things
Okay.
like that.
Let's see. Okay, you're fading out. um,
Oh, sorry.
yeah, yeah, that's okay. But thank you for that. Um, yes, there is posted on Blackboard board a homework submission statement. Gives the rules about how you should submit homework. Also, write your name on your homework paper. Okay. I know, well, I didn't grade your homework, Mr. Miller did, but for my other class I did. And figuring out which file went with which person was a little bit hard because there was no name on the piece of paper. So if you'll do that, it'll help. Um, yes, and also if we can't read it, we can't grade it. So do check your PDF file before you send it in and make sure it's legible. Just trying to see if, okay, any other comments? Make sure you show your work. We'll count off if you don't show your work. And okay, this is not the ideal learning format. It's better if we could meet in person in a classroom and talk to each other normally, but we don't have that option right now. Uh, so we have to make the best of it. And speaking from experience, doing the grading, everything this way takes me probably 5 times as much time as a normal class would, an in-person class. Okay, I have to suck it up and do it. It's going to be harder for you too, because you've got to get things submitted as PDF files and things have to be done on time. I have also been thinking, yes, and you have a homework due Friday. Okay. So I hope you're working on that. And then you have an exam the next Friday. And I talked with people in the department and I have decided to do the following. I'm going to ask you, everybody's going to need to have a camera and I'm going to be looking at you while you are taking the exam. I'm going to post the exam on Blackboard. Probably about 7:30 in the morning or so Friday morning, so that you can access it. And then I want for you to be sitting there taking your exam, and I want to be able to see you while you are taking your exam. So if you don't have a camera on your computer, you're going to need to maybe go to the university and use one of their computers. Good morning. Okay, and you're going to need a good internet connection. Okay, I can't help you with that. You're going to have to find a good internet connection. The university should have a good internet connection, and God forbid mine goes down. But yeah, I'm a little nervous about this, and I think we'll do a practice run next Thursday just to see if we can all make it work. So I'll find an old exam I gave in this class and post it on Blackboard Thursday morning at 7:30 for our practice run. Okay. And then you can print the exam out so you can take it and write it on paper, just like you usually would. Or if you know how to do a split screen, you might be able to have both the Zoom and the exam appearing at the same time. But somehow you've got to be able to see the exam, and I've got to be able to see you. It'll end at 8:55. And once it ends, I want you to put the exam in one PDF file. Okay, you should be pretty good at that by next week. And then email it back to our class email. And I'll write all this up and put it on Blackboard too. That's how we're going to do it. Practice run on Thursday, just to see how it goes. You do need a good internet connection. You do need a camera so that I can see you while you are taking the exam.
By next Thursday, you mean the day before the exam, or do you mean the tomorrow?
The day before the exam. Yeah, right. This is Wednesday, right?
Yeah.
Oh my, I have been sitting in my house for 5 months now, basically, and the days get mixed up. It's
fine. I hardly ever know what day of the week it is.
I mean, I'm usually.
But I was going to make a suggestion.
For traveling, I usually do lots of things. I see lots of people. I go to conferences. None of that this summer. It's like living in an emotional desert.
If I may make a suggestion, maybe you want to make it next Tuesday, if possible. So this way, if it doesn't work out, you won't have to scramble to change everything.
Okay, that's a good idea. Okay, so we'll do practice run on Tuesday and consider it a review for the exam. How about that?
All right, if everyone else is cool with it.
Also, kind of relating to that, how would that work for students who have the DRC accommodation of extended test times? Would they be allowed to stay after 8:55 if need be, or what would be the plan for that?
Could you start it before 8, Mr. Levy? Oh, yeah. Okay, so that means I need to fill out a form for you probably too. For the, okay. We can talk about this later, but could you start half an hour earlier?
Yes, ma'am.
That would make it easier for me, because the problem I have is that the hour after I teach your class, I'm teaching another class. So it's going to be hard to do both. Okay, but we could start it earlier for you, or if you need, and I will fill out the form that needs to go to the administration. Okay.
Okay. Thank you.
You're welcome. Okay. Anything else before we get started? All right. I'm going to share the screen. Okay. Actually, I am now talking about material that will not be on your exam. It'll be on exam 2. not exam one. For your first exam will only cover the homework that's due Friday and the homework that's been graded. So the first two homework assignments only are on the first exam. Okay. And we had some, all right, let's see. This is kind of where I left off yesterday, but you had some questions. Let me just talk a little bit about those. Yeah, from the questions from before class, there was a question about x minus a. That is indeed equal to minus a minus x. Okay. I factored a minus 1 out. And if you multiply through, you'll see you get the same thing. Okay, and what was I saying about number 4? Let me get you started on number 4. I think number 4 probably is a lot easier if you'll do it as a sum of two limits. So you want the derivative of f of x is equal to x plus the square root of x. So that is, okay, I'm going to use the x approaches a definition. By definition, nope. If I'm using the x approaches a, I need to call that a. Because x represents the numbers that are getting close to a. Okay, the limit as x approaches a of f, whoops, oh, well, okay, that's all right. No, f, nah, all right. F of x minus f of a over x minus a. Okay, would now put in your function. Whoops. I thought I'd gotten past everything that I had planned. So that's going to be x plus the square root of x minus a plus the square root of a over a. Oops, over x minus a. And that's actually, you can break it into the sum of two limits. Okay, x minus a. I'm going to rearrange terms in the numerator. And okay, the limit laws now allow me to break this into the sum of two limits. Because I've got this, okay, I can write the fraction inside the limit as x minus a over x minus a plus the square root of x minus the square root of a over x minus a. And then I can write it as this is one of the limit laws. I think you'll find that number 4 easier if you do that. If you don't do that, yeah, you're going to have trouble, I think, rationalizing. But yeah, if you do this, it'll be easier. Okay, let's see. This is about the homework and not about what I was planning on saying today. Let me do one more compute the limit example because, okay. I'm thinking. What if I take the derivative of 1 over x cubed? Yeah, for your homework, you must use the definition. That is that you must take that limit. The limit as x approaches a of f of x minus f of a over x minus a, or the limit as h approaches 0 of f of a plus h minus f of a over h. You may not use the rules that I'm talking about today. They are for later, after we understand what a derivative is. Okay, how about this function? Find f prime if f of x is 1 over x cubed. So this is a little bit harder than number 5. And so f prime of x is the limit. I'm going to use x approaches a of f of x minus f of a over x minus a is equal to the limit as x approaches a of 1 over x cubed minus 1 over a cubed over x minus a. Okay, so I've got a fraction in the numerator. I'm going to get a common denominator and hope that helps me out. And the common denominator will be x cubed times a cubed. That's the big bar there. And that's going to be a cubed minus x cubed in the top. Just checking my arithmetic here. Okay, it looks right. All right, so let's see. And then let's get rid of the complex fraction using algebra. No, I'm looking at the wrong line. Okay, so a cubed minus x cubed is in the numerator. And using a over b over c over d is equal to a d over b bc. That's going to give me x cubed a cubed times x minus a. Okay, so I've got x minus a as a factor in the bottom. I need it as a factor in the top too. And it is. I'm going to divide it out to figure out what the other factor is. I need to write the x term first. And then plus 0 plus a cubed. Okay. So I'm dividing x minus a into a cubed minus x cubed, but I've written it in a different order and sort of put in the middle terms so that I can do my little algorithm. Okay, x goes into minus x cubed minus x squared times, and I magically changed the color. Okay, so minus x squared times x minus a is minus x cubed plus a x squared. And remember, you subtract the blue from the red. So x cubed minus x cubed is going to be 0. And 0 minus ax squared is going to be minus ax squared. And I'm going to bring down the next term. Okay, again, x minus a goes into minus ax squared minus ax times. So, and then multiplying minus ax times x minus a, that will give me minus ax squared, and then plus a squared x. Okay, and again, you subtract, and that part's 0. And this is minus a squared x. Okay, now bring down the last term. X goes into minus, I don't want to write that 0, it's kind of distracting there. X goes into minus a squared x minus a squared times. So you get, okay, minus a squared times x minus a is minus a squared x plus a cubed. Okay, and notice when you subtract this, you get 0. So it went an even number of terms, so times. So a cubed minus x cubed, that's what we had to start with, yes. A cubed minus x cubed over x minus a is equal to minus x squared minus ax minus a squared. Now, I don't know, the H definition might have been easier to use here, and the algebra would go a little bit differently. But it did go an even number of times, so that means that, okay, let's see if I can come back up here. What I've got is the limit as x goes to a of x minus a times minus x squared minus ax minus a squared over x cubed a cubed x minus a. And now x minus a is a factor on the top and on the bottom. Okay, so now I can cancel the x minus a's. The 0 over 0 problem is gone. And I can just do a direct substitution. And that's going to give me, oh, that's unfortunately in the way there. Minus a squared minus a squared minus a squared, which is minus 3a squared. Oh, I forgot. Okay, I forgot something. Okay, namely that I forgot my denominator. Okay, so I knew that didn't look quite right. X cubed a cubed over a cubed, and that's a to the 6th. So it's minus 3 a to the minus 4th. And okay. So for f of x equal to 1 over x cubed, f prime of x, using x instead of a, is minus 3x to the minus 4. Okay. That's another example. In fact, that one's harder than number 5. I hope maybe that helps. Yeah, each problem in 1 through 6, again, use only the definition this week. If you use the differentiation rules, which we are starting to talk about for this week's homework, you will not get any credit for those problems. You work that way. Yeah, the next homework after the exam, the first one after the exam, we'll start using the differentiation rules. So okay. We started talking about the differentiation rules a little bit yesterday. So this is not on the exam. Next week. We are now talking about materials that will be, you get homework on the week after the exam. Okay, so any questions? Okay. Write it until you put in A for X. Okay. It's not correct if you leave it off. Yeah, so, okay, so there's the definition. I always write the definition first. Then I filled in my function. And notice I kept limit. The limit only goes away in this step right here when I actually put in A for X. Okay. Okay. Okay, so maybe so the right stuff I write, I don't know, perhaps I should not write so much before class because I don't seem to be able to judge the amount of space I need, but I'll work on that. Okay. All right, so differentiation rules, which not on the exam and not on this week's homework. But we are starting to talk about them. Okay, so yesterday we actually proved using the limit definition that if your function is a constant function, the derivative of that function is 0. Okay. And we also proved yesterday using the limit definition. Yeah, that's why definitions are so important. We're learning some shortcuts, but the shortcuts work because you use the definition to prove they work. The definition is underlying everything, and that's why you must understand it. So yesterday, if f of x is x, we showed that f prime of x is 1. And if f of x is x squared, we showed that f prime of x was 2x. Okay, so let's do one more of these. I'm going to prove this statement. Actually, this is true in general for n a real number. Oops. No. A fixed real number. As long as the function is defined. Something like, well, if you have n equal to a half, then that you have x to the 1/2, well, that's equal to the square root of x. That function is only defined when x is greater than or equal to 0. So you have to keep in mind what the domain of the function is. But as long as the function is defined at x, and f of x is x to the n, then f prime of x is n x to the n minus 1. Proving this in general, especially, well, for the positive integers, if it's a positive integer, you can actually write out a proof. It's not too hard. By doing the kind of division I just did with that a cubed minus x cubed over x minus a, doing that kind of thing. If n is not a positive integer, it's a little more difficult, but I'm not going to, so bottom line, I'm not going to prove this statement. We're just going to use it. We do have 3 examples where we did prove the rule up above. So you have, it's at least plausible that the rule works the way we said it did. Okay, so let's do the rule for x cubed. Show that f of x, f prime of x is equal to 3x squared when f of x is equal to x cubed. Okay, so if I'm proving that this is true, I'm going to go to my limit definition. And okay, now I'm using the h goes to 0 definition. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, then put in x plus h for, yeah, and that's in my variable there, f of x plus h. So yeah, let me write that out by the side here. If f of x is x cubed, so f of x plus h is x plus h cubed, right? F says take whatever is inside the parentheses and cube it. So if you got x plus h in the parentheses, you want to cube that whole thing. And okay, now, well, I want to expand on the top. That's some algebra I can do. And okay, I'm going to use the binomial theorem. If you don't know it, you just multiply x plus h times x plus h times x plus h. Do it 2 at a time. But the binomial theorem says that x plus h cubed is x cubed plus 3x squared h plus 3x h squared minus x cubed over h. All right, did that help? Well, I think so, because, well, right now there's an x cubed and a minus x cubed, so that adds out.
Wouldn't there also be a plus h cubed as well?
Yes, I was just noticing that. Thank you. Yes, sir. Absolutely. Kind of left off the last term. Okay. There. That's better. Okay. Now, okay, add out the x cubed. Okay. And notice that's the x cubed and minus x cubed. Those are the only terms that don't contain an h as a factor. Okay, so now we've got the limit as h goes to 0 of 3x squared h plus 3xh squared plus h cubed all over h. Now I can factor an h out of the numerator. And notice I keep writing limit, limit, limit. Okay. You need to do that too. You don't stop writing limit until you put in 0 for h. And we cannot do that yet. We cannot do that right in here because I'd get 0 over 0. That's not 0 over 0 means you don't know, basically. It's not a number, it's a form or a limit. Okay, but continuing, I can factor an h out of the numerator. Okay. And now I've got h as a factor on the top and the bottom. So I can factor out an h. If you're using the h goes to 0, you got to be able to factor out that h at some point. And that's equal to the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Now I can use direct substitution and put 0 in for h. When I put 0 in for h, the limit goes away, that limit sign. So now I don't write it anymore. But that's going to be 3x times 0 plus 0 squared, which is just 3x squared. So somebody just entered the waiting room only 40 minutes late. He can wait for a minute. Okay, so it's the derivative is 3x squared, and that proves it. Okay, so we have proved that statement. We will not prove this one ourselves, but we're going to use it and assume it. It's a little bit beyond us right now. Any questions? Okay, let me go back and let this guy in. There's not much. So disruptive. Okay. Well, so then we have two little rules. Derivative of constant is 0. Derivative of something of the form x to the n is n times x to the n minus 1. So the derivative of x to the 4th is 4 times x cubed. The derivative of
Professor Kendi, are you back on the notes?
Oh, yeah, I didn't do it properly. I'll go back. Thank you. I have to share the screen here. Okay, that's what, all right. Thank you. Okay, now you should be able to see my screen. Okay. Okay, so we have those two little rules. Here's another one. If you have a function that's differentiable at x, oh yes, and I'm using a different notation here. The derivative of a constant times f of x is just the constant times f prime of x. So let me talk a little bit about notation. If you have if f is a function differentiable at x, then f prime of x means the derivative of f at x. And you also see this d. So df at x, all right, means the same thing, that d in front. And you also see sometimes df dx, or if you write, if you have f of x is equal to y, you also will see things like this, dy dx. These two are what are called, this is Leibniz notation, and there are times when it's really handy, but I'm going to switch back and forth between these as convenient. They all mean the same thing. Okay. And it's a little bit awkward to write, well, if I use the prime notation, I guess I could do that, but I don't know, that looks a little strange. So instead I use that other notation, but it just means derivative. Okay, so let's prove this statement. If f is differentiable at x and c is a real number, then the derivative of of c times f of x, so you can just pull the c out, okay? It's c times f prime at x. Not much can be pulled out, but constants can, constants that are multiplied. All right, well, why is that true? It's very easy to prove. Using the limit laws, the derivative of c times f at x would be, by definition, the limit as h goes to 0 of c times c, okay, so I'm right here, c times f of x plus h minus c times f at x over h, okay, because of my function is this one. But now the limit laws say that I can just take that c out of the limit. Because maybe I should have put another step in here, because, okay, this is the same thing as the limit as h approaches 0 of c times, so I factored it out of, whoops, minus f of x over h, that's equal to that. Okay, so I factored the c out of the expression inside the limit first, but once you have it in this form, then it can be taken out of the limit using the limit laws. And this statement should go right here. Okay, but this is just the definition of f prime at x. So this is c times f prime at x, and that proves it. Oh, let's see. Well, I was going to do this one, but yeah, let's do it. And then do a couple of examples. Let's do some examples right now because we're running out of time. Okay, so we have so far, let's see if I can review the rules we got so far. We've got one, f prime of a constant is 0. No, I didn't write that correctly. F of x is c means that f prime of x is 0. C is a constant. F at x is x to the n, as long as this is defined, means that f prime at x is n x to the n minus 1. And the, let's see, so capital F of x. No, right the way I did. If you have a constant times a function, that is just the constant times the derivative of the function. Okay, so let's do a few examples. Find f prime if f of x is 3x to the 6th. Well, f prime of x would be 3 times, okay, I can pull that constant out using this rule number 3. So it's 3 times the derivative of x to the 6th, which is 3 times 6 times x to the 5th. So it's 18 times x to the 5th. Another one. If f of x is the square root of x, find f prime of x. F prime of x, well, before I do that, f of x is the square root of x, which you can write in exponential notation as x to the 1/2. So this fits in with this rule number 2 up here. Okay, going to use that one where n is equal to 1/2. And that means that f prime of x why is it not writing? Oh, for that. Oh no. Let me dock it. Technology. It's got its problems. It just puts another layer of stuff you have to worry about. See if that helped. No. What's going on here? I don't know. I know what. Start a new one. Okay. So we have f of x is the square root of x is x to the 1/2. And that means that f prime of x is n x to the n minus 1. So 1/2 times x to the 1/2 minus 1 is 1/2 times x to the minus 1/2, which you can leave in this form, or you could write as 1/2 times 1 over x to the 1/2. Remember the negative exponent means it's really in the denominator. And that's 1/2 times 1 over the square root of x is equal to the same thing as 1/2 times the square root of x. And I think that's enough for today. Stupid pen gave out, or I don't know what happened. Any questions? Okay, let me go back. Okay, well, that's it for today. I guess I will see you tomorrow. I do have an office hour this afternoon at 1. Okay. So stick around if you have questions. Otherwise, you can go.